Hi, I'm Paul. We are doing Leetcode Must Know interview questions. Today's challenge, construct quad tree. To be honest, I had never heard of a quad tree before seeing this problem. And it really, just explaining the problem is is harder than solving it. So bear with me while we, set it up. But here's the challenge. Given an n by n matrix grid of zeros and ones, we want to represent grid with a quad tree, and the method that we write here, called construct, is going to return the root of the quad tree representing grid. Yeah, we'll look at an example of that. It's actually it's kind of hard to decide in what order to present this, but all right, so a quad tree is a tree data structure in which each internal node has exactly 4 children. Actually, let me scroll this so we can see the definition. Okay, here's the node class. Each internal node has exactly 4 children. Those 4 children are top left, top right, bottom left, bottom right. Each node also has 2 attributes. One, val. That is a Boolean. That is true if the node represents a grid of ones or false. Well, in this case, I guess it depends on the language that you're using, but the way it's defined here as a Boolean would be false. Wait. I'm sorry. Okay, now I'm getting confused here. No, the val is true if the node represents a grid of ones, and it is false if the node represents a grid of zeros. Now, let's see, you can assign the val to true or false when is leaf or false. Okay. Now, if the grid is not all ones or zeros, it doesn't matter what we set val to. We can set val to anything, true or false. When is leaf is false. Is leaf indicates that the grid contains a mix of ones and zeros. All right, is leaf is true if the node is a leaf node on the tree. It's false if the node has 4 children. And the reason that we have children is that it is a mix of ones and zeros. All right. We can construct a quad tree from a 2-dimensional area using the following steps. If the current grid has all the same value, all ones or all zeros, set isLeaf to true. Set val to the value of the grid. Set the 4 children to null and stop. Okay? If the current grid has different values, set isLeaf to false and set val to any value and divide the current grid into 4 subgrids. Okay. Now when it says the current grid, we're going to start from a grid. But because it's a divide and conquer problem, we may need to split the grid into subgrids, into 4 subgrids. Top left, top right, bottom left, bottom right. So when we say current grid, that is not necessarily the top level grid. We may have to split the top level grid. We may have to split a child of the top level grid. Where do we leave off here? Yeah, and then recurse for each of the children within the proper subgrid. You don't need to read this section for solving the problem. All right, hang on a second. I'm going to read it and then decide if we should read it. All right, we probably don't have to read it. Well, here's, I guess, the simplest possible example is if we got a grid, and let's look at the constraints here. Grid. All right, so the grid is going to be, it's square, and the size, the height and width will be some power of 2. So where a power between, where the power is between 0 and 6. So 2 to the 0 would be 1. Exactly sure what we would do with a grid of 1. But it could go up to 2 to the 6th, which is what, 64? Okay, so it's going to be a power of 2. Here's a very simple example. We're going to create a quad tree. All right, here is the top level node is leaf 0. It's not a leaf node. It has 4 children. The 4 children are the top left, that is a leaf, and the value is 0, because all of the values in that in that subgrid, well, there's only one value, is 0. Top right, that's a leaf, value is 1. Bottom left, that's a leaf, value is 1. Bottom right, that's a leaf, value is 0. So this one here is probably a more useful example. All right, on this one, here's the original grid. We split it into 4 subgrids. Now 3 of those are going to be leaf nodes, because top left, they're all 1s. Bottom left, they're all 1s. Bottom right, they're all 0s. So we can see that here. Top left, is it a leaf? Yes. Value is 1. Oh, top right, we're going to come back to that. Bottom left, is it a leaf? Yes, value is 1. Bottom right, is it a leaf? Yes, value is 0. Top right, is it a leaf? No, because there's a mix of 0s and 1s in there, so we've got to split it again into 4 subgrids. Now, as it turns out, those 4 subgrids are leaf nodes. So top left is all 0s, top right is all 0s, bottom left all 1s, bottom right also all 1s. Okay, let's, so we'll look at these as we need them, but there are several constructors that we can use for the node class. All right. All right. I think that we can make grid a class variable. So put that here, right, int grid, and we'll say, first thing we'll do here is say this dot grid equals grid. Okay, now it would be, I don't know, that space. So what we want to have here is a function that we can call recursively. It is going to take, well, it really doesn't need grid as an input if we have grid as a class variable, but it would need, let's say, return build tree. It would need to know the coordinates of the top left cell, which for the first call would be 0, 0. And it would also need to know what is the well, the you know, the width, the height, the width, you know, I mean, well, for a Java array, we call it length, but it would need to know the let's say the width of the grid, this I don't know, the size of the grid, the size of one side of the grid. Let's say it that way. All right. What can we do with that? Build tree. All right. The inputs. Well, could we say row and column? Yeah, that might be good. We could say row, column, width. Row, column, width. Okay. Now, first thing is everything in this grid the same value? We need we should have a subroutine for that. So let's say if all same and pass in row, column, width, we'll get to all same in just a second. Okay, that means that this is going to be a leaf node. So we'll return a new node. What does a, okay, so what is the leaf node looks like? We can probably use this one here. So the val, it needs the val 0 or 1, and isLeaf is going to be true. So what is the val? Well, val would be grid row call equals 1. Is that going to work? Yeah, because we need a Boolean here. And if it's 1, then the Boolean is true. If it's 0, the Boolean is false. So that'll give us the val, and then isLeaf should be true. All right. So let's do all same, because this is pretty simple. Private Boolean all same, and we're passing in int row, int call, and int width. Okay. Let me think about this for a second. Okay, so we'd rather not iterate through every cell to find out if they're all the same if we don't have to. So let's do it like this. For int I equals row I is less than row plus width I plus plus. Okay, and then about the same thing for the next one. For int j equals column j is less than column plus width j plus plus. If grid I j is not equal to grid wait, is this going to work? Yes, this will work. It's not equal to grid row call. Okay, so we can iterate through all of the, we can iterate through with a nested loop all the cells of the grid until we find a cell that is not equal to the cell in the top left. If they're all the same, then yeah, we're going to have to go through all of them. But if they're not, then we can get out early. If we find one that is not equal to the first value that we saw, then we can return false. Let's see, I need one more bracket here. And if we get through the whole thing and we have not returned false, then we'll return true. Okay. All right, if all same, well, yeah, then then it's a leaf node. But if it's not, then we're gonna have to split this thing into 4 pieces. All right, so we will do this. Final int half equals width divided by 2. And we are going to return a new node, but this node is going to have 4 children. All right, so for val, val I think can be anything for this. Can be anything because it's mixed. It's not a leaf node. So for a leaf node, we'll call false. I mean, let's take a look at the constructor that we're using here. We're using this one, where we're going to send in val, we're going to send in leaf, and we're also going to send in the child nodes. Okay? And we can do that with recursive calls. So, it's going to be too long. Let's just do it to right here. All right, top left, build, tree, row, column, half. Is that right? Yes. Okay. Yeah. So that's the okay, so that's the top left. Row and column stays the same as the top left corner, but the width is only half of what it was previously. All right, build tree, comma. Let me just copy that. All right, so this will be, you know, I forgot what order they're supposed to come in. Top left, top right, bottom left, bottom right. Okay. So this will be top right. All right, so in this case, the row is the same, but the column is going to have to be moved over. So we get to the top right, subgrid. All right. Next, we need bottom left. So this is going to be, we're going to have to move the row down. The column stays the same, and we use half. All right. And this is going to be the bottom right, in which case we have to increment the row and the column. What just happened there? Let me move this over a little bit. Okay. Half, and that's it. Get the other parentheses back here. Okay. Really, I think that's it. All right, grid. We've got a grid, and we have a routine that builds trees. If we give it builds quad trees. If we give it a row and column at the top left corner and the length of the grid, is everything the same? If it is, that's a leaf node. If it isn't, we're going to have to split it into 4 pieces and recursively return the node with its subnodes. Okay, we've got kind of a simple routine here to determine whether all of the values in a given grid are the same. A little nervous about this, but I can't think of anything to do with it. Let's run it. Compile error. What is that? Int row call width identifier. Oh, shoot. Okay, sorry. 51. Int row, int call, int width. All right, let's go again. What happened? Whoa. All right. Let's move this over. Base case is passed, and we'll submit. It's kind of interesting. Wow, there really is not a very wide spread of runtimes on this. Okay, so let's see. What is the runtime? I mean, worst case, I guess we would have to iterate through every cell to check and see if they're the same. So that's n squared. And we would have to do that. All right, every level of recursion is split into 4 pieces. So it's like n squared times log n. I'm not sure that's right. I mean, it might be base 4 log n, but I think it's going to be something like that. N squared times log n or base 4 log n. Let's see. Just n squared. Okay. I don't know. I guess you could say that swamps out the log n. But okay, yeah, n squared. Anyway, that's it for, I think that's the last, oh, wait a minute, no, I think there might be one more divide and conquer problem. Well, anyway. So that's it, divide and conquer, quad tree. Yeah, we just, we need just one routine that will take grids and build a quad tree. or yeah, take the, you know, the basic information about a grid and build a quad tree. And we can call it over and over. We can take the grid, we can split it into subgrids, but we're still passing it to the same routine. So anyway, that's the you know, concept of divide and conquer. That's it. This has already gotten pretty long. So I hope you enjoyed it. Please feel free to like, comment, subscribe, and see you next time.